300 participants.
Yeah.
If more than that, we should shift to the other one in 1,000. Yeah.
Yeah, because Dr. Heri is the chairman of the Indonesian Road Association construction. So I think it's very easy for Dr. Heri to, take participants.
Thank you, Pak Wayan. Yes, thank you. Introduce me. I chair of the Road Association of Jakarta area. So easy to me to broadcast to all our members, Mr. CHEW. Especially for free of charge. Yeah.
Hello. Zoom meeting.
Bapak Wayan.
May not lah.
Saya lihat ada beberapa teman ini di sini.
Pak Wayan.
Iya, Pak Yayan, apa kabar Pak? Ketemu lagi.
Saya dengar kabar tentang pajak ya di Medan, Pak.
Iya, betul. About kira-kira 2 bulan lalu ya, 3 bulan lalu mengalami kecelakaan itu. Tapi udah baik sih sekarang.
Udah baik.
Sorry, because I was knocked out. I don't know what that actually.
Sudah kan? Tapi kan?
So, Professor CHEW, you are off today, yeah?
No. I'm working. But if you want to arrange a physical, I can take leave and come to Jakarta. But since you did not, I come to office.
Oh, I see.
It's okay.
But the semester is already finished,
yeah.
Right?
Yeah. I was busy making 200 examination script last week. So last week was very bad.
You mean your student is 200?
Yeah, I have different classes. Total is about 200. Yeah.
They will keep you busy to grade the exam.
All right. So that's why you tell me Monday. I say, hey, Monday I want to sleep. Yesterday I want to sleep. I just finished my yesterday. Actually, finished marking my yesterday. Oh. So I want to sleep afternoon. So yeah, today I'm fresh. Today I can whole day.
Yeah, this webinar will take 2 hours. Hopefully it will be completed.
Yeah.
So sorry about too late. Maybe in Singapore now it's 4 o'clock, right?
Oh no, normal. I can talk for 4 to about 5:30 if I try to control my time, and then leave some time for some questioning. You know me, if you don't stop me,
no, definitely I'll stop you.
Good.
Dr. Heri will stop you.
Jadi, Wayan, sudah pukul 3, apakah mau kita mulai atau masih menunggu?
Kalau saya, Pak Profesor CHEW udah di sini, kalau dari kami sudah mulai, Pak Heri kan juga sudah, teman-teman. Kan?
Professor Wayan, before start, let me introduce 2 very important person. One is Mr. Tan. I think you met him last time. In a sense.
Oh yeah, Mr. Tan, right?
Yeah, he owned the Statnamic machine. Yeah, so he's more than happy to support and ship to Indonesia.
Yeah, good afternoon, Mr. Tan. Nice to see you again here, even though it's in a webinar. Online. So nice to meet you.
Yeah.
Yeah. Good afternoon.
Good. Now, then we also have another gentleman. Let me see. Is he still there? With this, Marcel, are you still there?
Yes, I'm still here.
Marcel, Mr. Marcel. Yeah, Marcel is one of the director of Ornament in Holland. And we say this is a good collaboration between us and Holland all these years. And he's so grateful that he's in Singapore. So I also asked him to join.
Okay, thank you, Professor. Nice to meet you, Mr. Marcel.
Nice meeting you too, for your invitation to join this. Looking forward to it, Professor CHEW and Professor Wayan.
Silakan Pak Heri, Pak Adib.
Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh, Bapak Ibu yang kami hormati.
Waalaikumsalam warahmatullahi wabarakatuh.
Good day, everyone. Welcome to the webinar on Statnamic method which is widely used in geotechnical engineering to determine performance and load capacity of piles. As your moderator, my name is Adib. I'm from PG of Aris. I would like to get you through the agenda and ensure that you have an informative and engaging experience. The agenda is the first one. We will have a welcome speech by Dr. Engineer Heri Fasa. He is Ketua DPD HPJI Jakarta and Ketua Satgas IKN Bina Marga, Chairman of IRDA, and the head of IKN New Vital Task Force. And then we will have an opening from Prof. Wayan Sengara. He is a professor in civil engineering and geotechnic expert from Institute of Technology Bandung. And then we will have Prof. CHEW, which will deliver the Statnamic and Statrapid new loading method for pilot test. He is an assistant professor in the Department of Civil Engineering, National University of Singapore. And then we will have question and answers, and then we will have closing. But we encourage you to participate actively in the Q&A session and take advantage of this opportunity to learn from our expert speaker. Before we start the agenda, let us hear the Indonesian anthem and followed by Irda Mas. Pak Fahri, silakan. Indonesia Raya. Terima kasih. Kita sudah dengarkan bersama lagu Indonesia Raya dan Masa PJI. Namun sebelum ke pembuka, before we opening remarks from Dr. Heri, we would like to thank to our sponsor. Sponsor acara hari ini ada dari Hutama Karya, Wika, Wijaya Karya, kemudian Pembangunan Perumahan, Jaya Konstruksi, Nindya Karya, Waskita, dan Modern. Kemudian ada juga dari Adikarya dan Wika Beton. Terima kasih kami sampaikan kepada para sponsor yang sudah mendukung pelanggarannya webinar ini. Baik, acara selanjutnya adalah opening speech dari Chairman of Tirda, DKI Jakarta. Please, Miss Dr. Heri Fasa. Silakan. Silakan Bapak Heri Fasa.
Masih mute mungkin ya. Pak Heri masih mute, Pak.
Saya telepon Mas Adib, saya teleponnya ya.
Oke, Dip, suara saya dengar?
Bapak? Sudah keluar.
Oke.
Sudah.
Okay, thank you. I lost my button. Thank you very much. Good afternoon. My name is Heri Paza. I am a chairman of Road Association for Regional of Jakarta, and also now as a chief of the group team to accelerate development road in new Indonesian capital city in Kalimantan. Thank you to join us in this webinar. Now already reached 85. We plan to have about 300 members to join in this webinar. I think as the opening, I would like to address the key factor of the pile foundation in design. In this occasion, I would like to thank to Pak Wayan and also Mr. Chew and Mr. Tang, and especially, if I not forget, myself from the Netherlands. Is it right, Marcel?
That's correct, yeah.
Yeah, it is from, yeah, I have a friend of mine in Netherlands when we developed our PDA test, Mr. Peter Middendorf, maybe you know him, yeah? We back to 1985, yeah? We brought a diagnostic system from TNO, from Netherlands.
Yeah, well, we've met at the time, I suppose. Peter's my friend, see him every day.
Peter Middendorf.
Yep, still in the company.
In some company?
In our company.
Yes.
Oh, in your company.
Yeah.
Yes, Henry, the Ornamic, Peter Middendorf and Marcel, they are the same company. They see each other every day.
Good. Okay. So in 1995, we brought the PDA test from TNO, yeah. So we learn more diagnostic of the condition, yeah, from the TNO, yeah. I was in that bed in 1985. Thank you. I'll say hello to Mr. Middendorf. Yeah. So in pile foundation, in my experience, the problem is how to install the pile foundation, yeah, especially for the bridge. Yeah. The bridge in Indonesia commonly is not easy to access. Yeah. So we should think about how to mobilize the foundation, the pile foundation, as simple as possible. Once we have a foundation, pile foundation chosen, then the problem again come to the what kind of the devices we need to drive it. Yeah, we don't have a big pile driving at the time. Yeah, so that all the condition should be based on the mind. Then after that, we also think about how to determine the pile bearing capacity. Again, for this case, in case of the road bridge sometimes crossing the river. So we should think how to test. If we test by the ordinary testing method, such as static loading test, Then we came to the issue how to have a reaction pile or candidates. After that, if it is a too big pile, so also we came to the problem how to test it, how to make sure the capacity of the foundation. All the thing is an issue that could be addressed during we design of the bridge, especially for bridge crossing the big river. We have introduced many kind of testing method. Static loading test is commonly used, and again in 1992 we have know about the wave equation. Then at that time we had introduced by the PDA and dynamic loading test. Then we interest to use the product from the TNO. So this system is quite simple to us to use in the field of the road bridge, especially a road bridge crossing the river. And then after that, we also have introduced and know by the TNO also about the Statnamic. Once have been done in Surabaya, I think, back to 2000. We have a big seaport, use the bore pile and then tested by the dynamic loading test. Now we have used for the big foundation, introduced tested by using the bidirectional testing method, or we can call this the OSIP test. But again, the precise to define the location of the sensor is will be determine the quality of the testing result. Again, also we should be delayed maybe about 30 days, because of the condition should become hardened before we can test it. So I think today, Mr. Cho and Pak Wayan, and then Mr. Marcel, to introduce to us the new method of the foundation. So I think we will take patience and then to try to keep all the introduction from him, and probably that can be make the advantage to us to use in Indonesia, especially in shortcoming project that we will finish in next 2 years. Thank you very much. Enjoy the seminar and have the benefit from the webinar. Thank you very much.
Thank you, Pak Heri. Thank you, Dr. Heri, for the welcoming speech. Agenda selanjutnya, next agenda, we will have an opening lecture from Prof. Engineer Iwayan Tengara. He is geotechnical engineer from Institute Teknik Bandung. His PhD, Doctor of Philosophy, is from University of Wisconsin, USA, and then Master of Science from Engineering Mechanics, University of Wisconsin as well, and then Master of Science in Civil Engineering, University of Wisconsin, and he was a bachelor degree in Civil Engineering Department, Institute Teknologi Bandung. Right now, he was geotechnical engineer for PT LAPI ITB and member of DKI Jakarta tim penilai ahli. And please, Prof. Wayan Tengara, the place is yours. Thank you.
Okay, thank you, Pak Adib. Thank you, Pak Herifasa, and thank you for all the participants for joining this webinar. Particularly, I would like to thank again Professor Chew, Mr. Marcel, and Mr. Tan for contributing to this webinar. So I just would like to give some introduction or just a brief requirement on the load test for bridge, particularly in Indonesia in this webinar. So basically, what we would like to have is what is the requirement of the bridge foundation for the design and the construction of the bricks. So we have foundation loading. In this case, for the foundation loading, we have need to provide the bearing capacity of the foundation and also the second integrity of the construction. So we have our own national standard, particularly for geotechnical engineering in general, but some of the requirement is also applicable or valid for several structures such as buildings and also bridge. In Indonesia, usually we refer the national standard to international standards, such as, for example, for bridge, we refer to American Association for State Highway Official, and also for building some other like international building codes, and also, of course, the American standard for testing material. Well, the purpose of that is to verify the bearing capacity of the foundation to the design load, and also to verify the design parameter that we use, so that our foundation has been according to the calculation, and so that the design is acceptable. So we have QA, QC, quality assurance, quality control for the foundation. And the second one is again for the integrity of the part. The load test is usually it's very common. Well, not actually very common, but some of designer propose to the owner. Usually we could do preliminary pilot tests, verifying the design parameter, result of the soil investigation data that we use for predicting the bearing capacity, and also for the purpose of optimization, we could do preliminary load test. We could do it from the static, PDA, whatever. We could do that. Well, during construction, so this is the requirement for the production files. So we have the requirement, let's say, like 1% of the production pile need to be tested. So for the load test, we refer to SNI 8460 2017. So this is actually the geotechnical requirement. Where within the geotechnical requirement, we have the particularly the specific for the pile foundation requirement. So this is the list. I think I saw it. So you can find this in SNI technique. What is the minimum factor for safety for the design? What is the tolerable settlement? What type of loading combination and support, lateral capacity? What is the requirement? And the last one is the pile test. What is the number of the pile tests? Whether it's axial, static, lateral, and tension, and also whether static or dynamic. For the load test, we have the axial requirement, axial compression, axial tension, and lateral. The PDA, pile driving analyzer test, is allowed actually in our codes, our standard, but it's limited to, like in Jakarta, for example, for building, is limited to 25% only. 20% of the total static load test could be replaced by the PDA. So this has been proposed last time by the Authority Committee of Jakarta, but I think also the SNI of geotechnical SNI also refer to that. Even now a lot of 40%. So I think this is too many. A lot of 40% of the total static load test could be replaced by PDA. So I think today's webinar would like to evaluate this requirement, and if we would like to be more stringent, like what conducted in Singapore, for example, Europe, United States, and also in Japan, for example, there is a limit number of PDA, but with more number of static or equivalent static, like maybe what we will discuss today, Statnamic or Statrapid load test. Okay, this is just another requirement. We need to do 200% of the design load. We can do more than 200%, but usually the requirement is 200%, and also with the maximum displacement allowed for the acceptance of the pilot test. Well, if we refer to S-stop, for example, for the particular brake design, we have this requirement for driven pile and also for bore pile, and the number of load tests is actually not stated clearly, but every different in zone we need to have at least one static load test, and for dynamic test minimum 2% of production pile need to be tested, but I think for the common practice in Indonesia we refer to the SNI, and then we need to have 1% to 0.75 or 1.3%, 1 to 1.3% need to be statically load tested. So this is the detail of that. So I think this is just for information on our case in Indonesia. Juga untuk rekan-rekan kita di HPJI untuk pengembangan jalan atau desain jalan, kita tesnya harus memenuhi requirement ini kan gitu ya Pak ya. Untuk melihat saja kembali. I have experience to review the Chinese code for a project of the high-speed railway that from Jakarta to Bandung that has many elevated structure, and then this is the comparison of the Chinese and the SNI. Basically, requirement is not too much different. We have static load test requirement, and also the PDA is not stated clearly. So, but what is more stringent in the Chinese code is the integrity test. So all of the bore pile particularly need to be cross-sonic lodging tested. So this is part of the pile integrity test. Well, Pak Heri already mentioned about the another option in Indonesia. I think it's quite well, not quite new. We had that bidirectional static load test conducted. Let's like in Suramadu Bridge, as far as I can remember, last time the bidirectional static load test was conducted, performed at the time. I think some PDA also. Well, again, I agree with Harry. The problem with this is, so we need to locate the cell. So there is theoretical interpretation of the as far as I can remember this test. So that the unit skin friction at the upper part needs to be equal to the skin friction at the bottom. I think some with the additional well again I agree with Harry capacity of the pile, which is simply we cannot determine yet, but we need to somehow decide the cell. So we have experience on conducting this load test in this test. So that's the building. Proposed static load test was equal to the friction at the bottom. 9,000 pounds is the additional long pile. I agree with Harry capacity of the pile, which is simply we cannot determine so we need to somehow decide the cell. So we have experience. So there's theoretic conducting this bridge, and we are not sure if the particle test was shown at the top and also the friction at the bottom. 9,000 is the additional long pile. So the limitation of this kind of test will be determine the return of the cells, some of the area of skin friction, and also relative to and also there there's some issue on the interpretation of those well, this is a new method in Indonesia. Statnamic and Statrapid, the STM and Eurocode, that is a good pattern to apply it in Indonesia. So later on, maybe the SNI need to be evaluated further because the Statnamic and Statrapid is more reliable compared to PDA. So that is some of the items or some of the things that we need to identify. I think hopefully this item can be useful for discussion later on after the Professor CHEW presentation. Thank you, Pak Adib. Thank you, Pak Heri. That's the end of my presentation.
Thank you, Prof. Wayan dan Suara. Terima kasih atas pembuka dan dari Prof. Now, sebelum Prof. CHEW, I would like to thank again to our sponsor. Our sponsor is from Utama Karya, and then Wika, Wijaya Karya, Pembangunan Perumahan, PT Pembangunan Perumahan, PT Jaya Konstruksi, PT Ninja Karya, PT Waskita Karya, PT Modern, PT Sirama Karya, PT Wika Beton, dan PT Adikarya. And now we will have the main keynote from Professor CHEW. Professor medical engineering. He was elected to be a council member of the Institution of Engineers Singapore, IAS, 2006 to 2011, and re-elected for 2011 to 2013. And then until 2018 terms. He is currently the president of Southeast Asia chapter of International Geosynthetic Society, IGS, and president of Singapore section of the American Society of Civil Engineering, ASA. Okay, now we will have Prof. Chew. Time is yours, Professor Chew.
Okay. Good afternoon. Thank you, moderator Adib, for the kind introduction, and thank you, Dr. Harry Vasa, for a kind introduction on your power testing or power design in Indonesia, and Professor Wayan for your nice introduction on the testing, especially the code requirement in Indonesia. I think that's a good education to me. By the way, can everybody hear me clear and loud? Thank you, moderator.
Yes.
Okay. I love to do face-to-face, more interactive lectures. So yes, understand this is a webinar, but still, I will talk. But anytime you have question, you can just voice it and then we can discuss, right? If it's too big a problem, too big a question, I will leave it to the end. But please, welcome to interact and stop me anytime. And then if I speak too fast, certain thing you want me to elaborate, just voice it out, okay? I will try to make about 2-3 stops in between to ask you for comment or question. Please respond, huh? Okay, everybody there? Good. Okay, so this is a good opportunity for me to share this, and I realize that Henry, you're familiar with TNO. TNO is defense-related organization in Holland, and they are the one who developed this method, Statnamic and Statrapid. All right?
Oh yeah, thank you.
Yeah, and you know Peter, you're going to see his picture later on. Yes. These are yes, so very good. Okay, so the title for this afternoon is Statnamic and Statrapid. These are method, we call it rapid load test. I'll explain. It's a new loading method for pilot test, and I'm happy for Professor Wayan mentioned sorry, who is someone has to take off the mic. Someone has to take off the mic. Yeah, okay, good. So these two methods, as Professor Wayan said, is a new method that has been well accepted by America, ASTM, and Eurocode. So in fact, when I was in the States, there are a few states like California and Georgia State and Arizona, they use it quite a lot. Okay, but it's popularly used in Japan as well, and in Europe, and now of course we are proud to say that it's very popularly used in Malaysia and Singapore. And we see the similarity between our rock and soil in Malaysia, Singapore, and Indonesia. So I'm confident that this can be a great help to Indonesia. Okay. Now, so I'm going to share about a few things. Number one, what is this test and what's useful for them? So need for the change from static. By the way, I should say very clear that this method is not to replace PDA, but actually aim to replace or substitute static load test. It's aimed to replace, that's what we hand, I would say that rapid load test, the method I'm going to introduce, actually is very consistent. The interpretation is very straightforward and give the result is very accurate as compared to static load test. So I'll explain that in a short while. And then I will say a little bit about codes, ASTM code, particularly important, and European code. I said briefly, and some other detail, you want to know more, we can have a second talk next time. Okay? Then I will jump on to section 4, which is talking about correlation with static test. I must convince you that the result of this rapid load test is equal to static load test. So therefore, you can use it with confidence. That's my duty to convince you in a short while. Okay. And of course, finally, I want to say that this rapid load test is very useful. Why? Because it will help your productivity. In Singapore, Malaysia, we improve our construction productivity greatly. I'll show you the numbers in Singapore. And I'm sure when you build a new capital city, you are in the fast track. You have many things to do. You do not want your parallel test to be on the critical part, right? You want the parallel test to be do quick, fast, and get over it, so you can do more important things. Okay, so that's called productivity gain, which I'll talk about. Okay, so that's the scope. Everybody still there? Yes? Marcel, still there, huh? Okay, good. Now, so let me being a professor in university, so we always like to go back to very, very basic environment. What is parallel test for? Parallel tests are needed for one or more of these four. Number one, to determine the bearing capacity of the part, which I'm sure so we want to know what is that. Number two, which is very important, which I saw in your Indonesian code, you also have it, to determine the settlement of the part when it's subject to n time. N can be 1.5 or n can be 2 times equal to 2 times of the working load, right? And we want to know that when part is subject to this, what is the settlement? Now, I will share Singapore, Malaysia experience on this. Because we build a lot of high-rise building, I'm sure your capital also, when you have a high-rise building, the settlement control becomes very, 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 very important. Because you cannot have a high-rise building that's shifting, you cannot have a high-rise building that have differential settlement, which is very dangerous. So therefore, in Singapore, Malaysia, we have very strict control on this, and that's where this rapid load test will be very, very useful. Okay. Now, number three, of course, related to number one, is we do determine the soil parameters used in your power design. And this is, for example, I think in Indonesia, you call it preliminary power load test. I'm sure you have this to verify your shaft friction and you verify your unit end bearing. So from here, you check your calculation. Okay, so that is, yes, to verify. And rapid load test can do. And you use the same strain gauges design as what you do in the normal static load test. So there's no difference. The only difference is the way you apply the load is different. So that's number three. And number four. Number four related to number two, which is very important, as what Professor Ryan just also highlighted. We need to ensure the quality of power are well constructed. And that we can do only at the proof load test. Meaning that you construct 100 powers, the engineer has to randomly select the powers after constructed, randomly, to check whether this power passed your criteria. And I'm sure your Indonesia code just now, I quickly saw the number that Ryan showed. Yes, it's there, right? You need to do this 1% or 2%. You need to do 1% of the number of powers to do this what we call proof load test. And in this proof load test, you cannot pre-select. You cannot pre-select. Meaning that you cannot pre-select. You must construct the power first, then you run the test. Okay? Now, of course, so therefore that means that bi-direction test is not suitable because bi-direction test, you put the jack inside and then you construct, which is not fair because by doing that, the contractor know you're going to test this part. So they will make sure the parts are very well constructed, which may not be the same as the other parts that may not be selected, right? So therefore, this is not good for proof load tests, okay? But of course, a lot of people will do PDA tests, which is okay, like what I said just now, except that the interpretation of result is a lot of problem, especially when you're ballpark. When you're ballpark, your dimension, your cross, the diameter or the cross section of the part is not going to be uniform, and the concrete quality is not going to be the same, especially a long part. I saw that your part is 80, 90 meter. It's not going to be uniform, so therefore your PDA interpretation is a big question. Okay, now good news is with all these four, you'll find that rapid load tests fit very, very well. Okay? Now, of course, traditionally we use the carnage block. Okay, carnage block we can see on the left hand side. This is a carnage block. Now, and then you also do what called steel plate. So the steel plate will save the height. The carnage block, the steel plate will have less height, but still the total amount is, the weight is the same. And then this is kind of combination of the two. I mean, this is a traditional method. It's a good method. It's a good method. Now, of course, traditionally we use that a lot of this. Okay, so I'm not saying this is not a good method. This is a very good method. Sometimes we do what called reaction power method. But of course, the problem for reaction power method, you need money to construct this 4 additional parts. Okay, of course, there are some people use the other production part to use as a reaction part, which in Singapore normally we don't accept, because by the time you pull it, the behavior is different from if you function it as a real normal part. So you construct additional reaction part. This need time and also need money, extra money. Okay. Now there's also one aspect that not many people are aware of, which is if you do a test part here, actually you need to have a clear distance between the test part and the footing of your carnage block or your steel block. You need this clear distance. Now, not many people are aware that actually this clear distance in the old day in ASTM is only 1.5 meter or like that. But today, actually, this is 2.5 to 3 times of diameter of the part. So if your diameter is 1.5 meter, your 3 times of diameter is going to be 4.5 meter. So therefore, you should have 4.5 meter here, and then another 4.5 plus 1.5. So actually this distance from here to here is going to be 10 to 20 meter, which is or 17, 18 meter, which is going to be very wide. So to support this wide area, firstly, you need to have this area, wide area. You occupy a lot of space in your construction site. Number 2, to support that, your girder, your beam design will have to be very careful. Okay. Now, so therefore, that is sometimes people may overlook this. You need to have a wide span. If not, if you put it too close, the stress bulk of this fella is going to unfairly make your part look too strong. You understand my point? If your distance is not big enough, the stress bulk here applied here, then will make this part, the test part, too strong, artificially too strong, which is not right. So therefore, this is some aspect that some people were misunderstood, right? Minimum spacing, 3D, whichever is greater. And I summarize different code of different country, different code. As I say, ASTM long time ago is 1.5. That is because at that time, all the parts are very small. But actually today, you look at ASTM, we are, look at all the later one is actually 3D, 5D, 4D. You see, a lot of these are going to 3 times the diameter of the part. So therefore, you really need a big span. Anyway, so all this will lead up to the problem I mentioned here. It takes long time to set up and also need test, and also high transport cost, because by the time you construct transport all this block, you need to run on the road, so that carbon footprint, okay, to some country like Singapore, we are concerned of that now, European, large space required, and you need labor intensive. Okay, of course, Indonesia, you may your labor cost may be very reasonable, but down the road, I'm sure your labor is also expensive down the road. In short, low productivity. So we want to improve on that. Now, more important is safety. So let me show you this. And maybe let me show you a video. Right, this happened in Singapore, and you can see the carriage block actually. Okay. Okay, can you guys see the video? Did you guys see the video? Can someone respond to me?
Yeah, yes, you can see your video.
But although it's kind of move frame by frame, but you see, right? You see the whole issue, huh? Okay, I don't need to repeat, huh? The whole issue is this carriage, this whole block actually can fail. So that is a safety issue. And the higher you go, the more dangerous you are. And the power that Professor Wayan showed to me or discussed with me, you're going to test for 1,006 tons. It's going to be very high. So safety is a big, big issue. Now you may actually on the internet, you can find a lot of this. This in Singapore, this in China. You can find, the picture speak for itself. Huh? So you stack the carriage block. Actually, there's always danger of this safety. So now that's the reason why in Singapore, right? Singapore Building Control, Building and Construction Authority, Singapore. A few years ago, we start to recommend, instead of doing this for high one, we change to building smarter. So therefore, we go to what we call rapid load test. Now, so advantage of rapid load test, let me summarize first. Rapid load test, reduce the setting up time. I'll show you very fast to set up one day. Limited space requirement, I'll talk to you about this. And less transporting because you don't need to carry that much of concrete blocks or steel plate. I'll show you. And the result is correlate very well with static load test. This is very important. So in short, and of course, it's accepted in ASTM and Eurocode and Japan code. High productive, I think to my words, okay, safe, fast, small space, and technically sound and accurate. So I want to sound this forward, remember. So rapid load test is safe, fast, small space required, and technically sound and technically accurate. This is important. As a professor, of course, this is important. The result is important. Okay? And that's what we call the rapid load test. Okay? So that's a kind of give you a quick overview, introduction. Okay? Before I tell you what is that method. Okay, 30 seconds. So far, everybody okay? Can hear me clear? Any immediate question? Please ask if there is.
Yes, very clear. Bapak Ibu, silakan kalau ada pertanyaan.
Okay.
If you have question, raise your hand or.
Yeah, continue. Okay, good. Good. Okay, let me sip a water. Good. Okay, now go to part 2, very important in the theory. So I'm going to share with the concept, I'm going to share with how the basic feature and how to interpret to get to the good result. That is important. Now we're all engineers, so we need with that reliable and good result. Okay. Now, building cartoon. Okay, all this pictures started with Peter. Okay, actually the whole idea is Sir Isaac Newton. We all know who is this guy. Actually, he observed that the apple will drop, and then we all know this theory, apple will drop is because of gravity. Okay, and the force of this dropping force is equal to m, which is the mass times the acceleration, isn't it? And the acceleration, of course, we all know here is gravity g. So therefore, in a very simple term, if you have 1 pound, you guys familiar with US system, if the mass is pound, 1 pound of apple will produce 1 pound force. This is force. In US, they have this unit called pound force, easy to understand. But today, of course, if it's 1 kilogram of apple will produce 1 kilogram, 0.981, which is 9.81 Newton. which is equal to 0.009 kilonewton, like that. 0.0. Mass is 20 G. What if this A equal to 20 times of G? Right? So therefore, 1 pound, sorry, I'm using green. I hope you all can see. 1 pound of apple will produce 20 pound force now. Can you see that? Instead of 1, I can produce 20 pound force now. So 1 kilogram of mass will produce 20 times, 1 kilogram times 20 times 9.81. So we produce 20 the equivalent force. So therefore, very good. You see that? Now let me stop here. Remember just now we said static load test. You need to stack up all the concrete block, very heavy. Now I can reduce that by 20 times. 1/20, reduce it by 20 times. So if you need 1,000 test load, I only need 50 tons instead of 1,000 tons of concrete blocks. So that's very beautiful. That's the whole idea. Okay, so that's Newton's law. But at the same time, we also need what we call this guy, second guy. Just now this one is a few hundred years ago guy. Newton is a few hundred years ago guy. But I also need a young man, 21st century man, to make the machine. So therefore, together, this is under TNO, use the TNO time, right? Peter, one of this, to develop a machine that you can blow up, zoom, go up 20 times of, and this force moving upward is equal to force moving downward. So the force is static. So that is a one. Statnamic is not an English word. It's static plus dynamic, and then they combine together, become statnamic. Static plus dynamic, huh? So that's how they create this word, statnamic. Okay, statnamic. Okay. Okay. Yep. Statnamic. Okay. So that is what Peter have done, and with the gang, and wait, where's my move? Yep. Now, so what they have to do is you make a machine like this. This is a machine that they make. Okay. Inside that, there's a white color. This is a mass. Mass is equal to 1/20 times of the test load. So if it's 1,000 tons, I only need this equal to 50 tons. Can you see that? Very little, 50 tons versus test load of 1,000 tons. Okay, I'm mixing the unit of mass and force. You know what I mean? Equivalent. Okay. So if you need 1,000 tons to test, I only need 50 tons of the weight. Okay. Now you need a special thing which is here, which is a special chamber, which I put a special fuel in this confined chamber, and then later on you have a gaseous expansion, expand very rapidly, and that will produce a large uplift force, and this uplift force will push the power downward. Can you see that? This force will push the power downward. That is the hollow test. That is the force that pushing the power down, and then you measure it. That's it. So that's simple. Okay, we can skip this one. Now I talk about this fuel. People may get worried. What is this fuel? Actually, this fuel is something like this. This is a fuel. Okay. Now and then you will light it up. Not for exposure. Actually, this is something like that. When you burn it, I have a video. I don't know whether it works or not. Let me try. When you light it with a secret lighter, right? You jam a little bit. You see, you can still hold it. Okay. Can you see the video? Yes, right?
Yes.
Hello? Yeah, okay. So you can see that actually no danger. It's just hot. Hold it hot. But if you put in a confined chamber, the volume expand very fast, and you use physics ball this thing, you'll push up this whole thing, and a force will come down. That's it. Very simple mechanism. that was developed by TNO at that time, and Peter was one of the key members. Okay, and yes, I think the company that I support technically, Mr. Tan and myself company, they can do this test for you. But after, and then these are some of the tests you can see. Maybe I can skip this, or maybe I can skip this test. Or do you want to see this one? Maybe I see this one.